spring season. The title is Economical Environmental Benefits of Building Municipal Building Energy System Upgrades. It's being presented by Myrika Seltzer-Williams. She's a Energy and Sustainability Manager at Practical Energy Solutions. Systems. Solutions. Yeah. And side note is Practical Energy Solutions was commissioned by Radnor Township 4 years ago to write the renewable energy and energy conservation plan for the township, and they did an excellent job. And a key part of this plan was to demonstrate to the community what can be done to a building, whether it's a large office building or your home, to increase its energy efficiency and reduce carbon emissions through heating systems. So, Myrika, please. Thank you.
Thank you. And I have my colleague Ben here. He's kind of the brains behind the operation. He's our lead mechanical engineer in our energy group. So I'm going to give a lot of kudos to him to the background of a lot of this. But as Dan mentioned, so this is a little bit of a timeline in very short summary. Originally, our conversations were around the renewable energy and conservation plan that morphed then into the adaptation of the Ready for 100 goals, which I would like to give Radnor a lot of kudos to sticking behind. A lot of municipalities that we have worked with have made these commitments, but not necessarily followed through with them. But Radnor has been a leader in just stick-to-itiveness, not only with the adaptation of the Renewable Energy and Conservation Plan, but also taking a step further for getting into the nuts and bolts of like what that meant. So in September 2023, we took that step further to facilities evaluations for this municipal building, as well as the Public Works facility, as well as the Radnor Activity Center, looking at energy analysis, solar, HVAC, as well as roof evaluations. That was a major need, not only from an energy standpoint, but just from a functionality standpoint. So the phase that we are in right now, which was initiated about August of last year, was the deep design of the roof replacement and the solar design for both this municipal building as well as the Public Works facility. So this has been an ongoing partnership and an ongoing commitment from Radnor's standpoint. Yes, sorry. So, I mean, in summary, that's kind of where we are. We're looking with design to. We had a couple hiccups with the bid process, but we're looking to start construction in July or August of this year. So we're in the bid process. Design is complete and looking for contractors to make it happen. So I want to take a quick little step back, especially with regards to the Ready for 100 goals that Radnor has made. This is a focus on public works and municipal buildings, taking into focus in the dashed lines the percentage of the energy use that is not consistent with the Ready for 100 goals. So basically on-site gas use. A little bit heavier with the Public Works facility. With this municipal building, there is a fair amount more of heat pump reliance, which is a good thing, even though it's sourced by boilers and chillers. So that's kind of a little visual, at least, of what we're working with. And that amounts to about 120 tons of CO2 equivalent emissions per year between the two buildings. So if we take a focus on the municipal building, some of the efforts that we have been pursuing is just increasing the efficiency of the equipment that is here. And there were definitely some issues in the roof. I mean, that's a couple pictures there, but in short, the roof was in need of repair, and part of the effort was to also bring that up to code to increase the insulation.
Was that a repair or replacement? That's really needed replacement.
Yep, so we will be fully replacing the roof, both here at the municipal building, but also at the Public Works building. It will be a full takeoff of, there's probably specific vernacular that I won't be able to, we'll be increasing the insulation, completely replacing the roof membrane, taking off the existing HVAC units and replacing them so that we will not only have a more contiguous and reliable roof membrane, but also we will be increasing the roof insulation. So that's one of the things here. The approximate insulation value of the existing roof is an R14 for those that it's below existing code, so we will be bringing it up to code, but also we will be increasing the, I guess we'll decreasing the permeability of the roof membrane. There's been a lot of issues with water infiltration, which has probably decreased the insulation beyond, I guess, below that R14 value. So we'll be bringing it up to code as well as sealing it off better. We're also moving from a black membrane to a white membrane, which will support more productivity and I guess resilience isn't quite the right word, but more production from the solar array. Black absorbs a lot of energy, whereas white will basically decrease the amount of energy, or like in insolation. So will increase the reflectiveness of the roof, which then decreases the amount of energy that will be going through to the roof. Feel free to jump in here, Ben.
The roof will still be flat. Yes.
The roof will still be mostly flat. I mean, it is pitched to drain, but it will still be a more or less flat rubber roof, but it will be more heavily insulated and with a more resilient membrane and with a white membrane.
Probably flatter than it is now, because now it's all bubbly and shaky, so.
Yeah.
Were there discussions? Can I ask?
Yeah, absolutely.
Discussions? Oh, do I need to?
Yeah, because they won't be able to hear
Okay.
you.
Were there discussions of a green roof? Would it be able to accommodate some, like a extensive green roof, which is the thinner type of green roof? Do we know?
So I am not sure about any discussion about green roof, but there will be some area of the roof, especially over this portion, that we're limited on the amount of solar that we can put on the roof just based on the capacity of the electrical distribution system. So there will be some area that would be available for green roof, but I'm not sure of any discussion between pros and cons between the two.
Bess, can you explain what you mean by a green roof? Because I think most people would think if you have solar panels, well, that's pretty green. So what do you mean?
Oh, right. So I was just wondering if, in addition to the white membrane, if there was any sort of discussion of any part of this project to have some sort of extensive green roof that would have thin layers of, whether it's gravel, when I mean green roof, like plants of sedums, that kind of green roof. Yeah. And they are starting to think about growing underneath solar panels. You would need more transparent solar panels, I think. So.
Yeah, the type of solar array that is proposed is going to be pretty typical of, it'll be maybe about a foot between I think it's about a 10-degree tilt of the panels. So there is possibility to consider that. I will point out that there were some areas of the roof that we had to make sure that not to put solar panels on because of the structural capacity, especially in the public works facility, which we can get to a little bit later. But there are some pretty significant areas where we couldn't even consider putting solar on, let alone potential for other types of like green roof. There will be some areas though that will not be covered in solar, and that could be a consideration for sure. So yeah, as far as the roof replacement on the municipal building, it's kind of it needs to happen anyway. There are significant leaks, issues with the roof as it is, but just increasing the insulation level of the roof, bringing it up to code, is about 3%, which doesn't sound big, but for something that needs to be done anyway, is about 3% of the entire building's energy will be saved, just with something that needs to be done. So the percentages here on the far right column, that's a percentage of the whole building energy use. So line by line doesn't look like a whole lot, but you start to add it up, especially with the things that are going to be done anyway. What's that? 6, 8, 12. It's like 15% of the energy usage of just kind of typical improvements. So, so insulation will increase, the reflectiveness of the roof will support further energy generation. But then there's also replacement of the rooftop units, and Ben, feel free to jump in here. He's our mechanical lead, so he knows a little bit more about the details of it, but we'll be, in short, replacing the rooftop units with heat pump units that are, as they are, gas heat, increasing their efficiency. And again, that's about 4% savings, which doesn't seem like a whole lot, but I do want to caveat that with the rooftop units only provide about like 20-ish% of the heating and cooling for this building. They are primarily there for like ventilation support, and then they condition the outside air that's coming in. So it's it primarily for ventilation, and then the rest is served by water source heat pumps throughout the building. So that's the bottom line there. But the HVAC, the rooftop units are going to go from gas heat to heat pump. So the little lightning bolt there, that is electrification of previously on-site gas consumption, which takes a stride towards the Ready for 100 goals of electrification. So we're increasing efficiency there, moving away from gas heat to the tune of, again, it seems small at about 4% of total energy usage, but in combination is good stuff.
What does EER mean?
So that's an efficiency. Yeah, you can.
Sure.
probably-
EER stands for Energy Efficiency Ratio. It's the ratio of the energy you have to put into the refrigerant compressor compared to the energy you get out of it. So when we have refrigeration systems, because we're making the refrigerant change phase from a liquid to a gas and then back to a liquid again, we get a lot of extra energy for free out of that. So when we put in, and the EER is in units of, I think it's watts per BTU. So we're putting in, for every watt that we put in, we're getting 12 BTUs out. And we can reduce that to be, consistent units. If we call it coefficient of performance is another efficiency term that's, watts per watt. For every watt that we put in, we get about 3 watts out because we're making the refrigerant change phase. So that's why refrigeration systems are so efficient. It's why we have this push for electrification. It's why heat pumps fit in nicely with solar projects and other sorts of sustainability efforts, is that combustion equipment is never going to be able to do that. Combustion equipment, even at its best, is approaching a coefficient of performance of 1. But with heat pumps, we can have a coefficient of performance of 3, 4, 5. They're even getting up to 6. And so to be able to be 6 times more efficient and using electricity, removing fossil fuels from the building, it really ties into all the other efforts, all the other sustainability efforts that you're also trying to achieve.
So that being said, the main systems in this building are water source heat pumps. So they're still heat pumps. They still have that coefficient of performance of like 3, 4 range. But they are fed currently by a boiler, which is fed by natural gas, as well as an air source chiller. Or,
Cooling tower.
Sorry, cooling tower. So the main heating source of the building will still be provided essentially by natural gas. However, the existing boiler is old. It is at end of life, and the intent is to transition to a condensing boiler, which pretty much maximizes the efficiency that you are able to get from natural gas combustion. And we're also moving towards a dual boiler, dual condensing boiler, so that we can have one of them down for the majority of the year unless it's absolutely needed for, the depths of winter. But the condensing boilers have really, really good efficiency. And so basically without completely changing out the entire distribution system in the building, which would be very expensive and very disruptive, we'll be increasing the efficiency, at least, of the source of those heat pumps.
Yeah.
And as part of that, there's an ongoing replacement of the heat pumps that are served by that system because they are at end of life. I believe it was 2009 this building was built. But they're generally at end of life and are needing to be replaced anyway, but they're being replaced with higher efficiency units, which is that 11 to 16 on that bottom line there, which is really the highest savings. Yeah.
The boiler is providing hot water heat? Okay. And is there such a thing as a heat pump that would heat a building such as this as the primary source? Or is the space too large for a heat pump?
Sure. Yeah, I can take that one. Sure. So in this, what you have in this system, we call it a water source heat pump system. And this is sort of a conventional approach where we have the heat pumps will extract heat from the loop when they need to provide heat, and they will
Right.
reject heat to the loop when they're in cooling mode. The boiler is maintaining the temperature of that loop. And the nice thing here with water source heat pumps is they only really need room temperature water to be able to extract heat from or reject heat to, which condensing boilers are very, very efficient at doing. The boiler you currently have is more of a conventional boiler. It's really designed to generate really hot water, for that hot water to be the primary heating element, heating fluid in the building. With water source heat pumps, it's just providing 70-degree water, maybe 80-degree water that they can just extract heat from. Condensing boilers reach their peak efficiency. The lower the water temperature they have to deliver, the higher their efficiency. So it's an ideal application for a condensing boiler, which is great in this situation. The alternatives to that, you could do away with the boiler and do away with the cooling tower if you had, for instance, a geothermal well field. And we did look into that for this project. We looked at drilling under the little creek out there and going into the baseball field, and we think you have the space, but the logistics are quite complex and expensive. Complex equals expensive. You can also have what are called air source heat pumps, which are more like conventional air conditioners that extract heat and reject heat just to the outside air. And they work very well, and they're really getting better and better. But there can be moments of the year where it's extremely cold outside and there's just not enough heat for them to be able to extract. So if we're designing those types of systems, we often factor in some sort of supplemental heat, whether it's electric resistance or a backup boiler that we hope we don't have to use very often, but it's there in case the heat pumps just can't generate enough heat. This building has a more conventional water source heat pump type system. For the time being, at least, we're going to continue to rely on the boiler and the cooling tower, but we're going to make those systems as efficient as we possibly can. And by providing that room temperature water, we can make the heat pumps themselves more efficient. Air source heat pumps, again, may lose capacity in the winter. Geothermal heat pumps may even lose capacity in the winter as the loop temperature starts to drop. Having that boiler on the loop makes sure that we are consistent throughout the year and can maintain the heat pumps, which are doing the majority of your heating and cooling, at their peak efficiency. So when you factor all those numbers in together, we end up with a more efficient overall system.
So in
even
terms
though we're
of
continuing to burn
CO2
some
emissions,
gas.
you're reducing CO2 emissions.
Substantially reducing the CO2 emissions by going to the more efficient boiler, and also by providing water temperatures to our heat pumps that allow them
Right.
to run at their peak efficiency. We can do better. I think if you compare it to a geothermal loop, probably the geothermal would use a little bit less energy. But there's so many other factors involved with designing geothermal that it didn't make sense for this building.
So just these measures, so the roof replacement, the HVAC, replacement of the boiler, and the ongoing heat pump replacements, is about 40 tons of, what was it, about 120, which is significant. And it's not even all of what is possible. So the next step then, as part of this effort, so first step, roof replacement, fix the leaks, make everything, watertight. It's important.
Sorry, there was a question I forgot to call.
Oh.
I was just going to ask where the solar panels play in. Does that factor at all into the heating of the water, or is that separate? And how much energy saves is? And if you're coming to that, I can hold this question. But how much CO2 equivalent emissions will be reduced by reliance on solar. How much, what percentage of the building's electricity will be powered by solar, and it's
Yeah.
on there?
Yeah, so
Perfect
I mean,
timing.
literally,
Oh.
just,
Perfect
yeah,
timing.
perfect,
Yep.
perfect segue. So it looks like the same little cloud, but it just happens to be a very close number. This is 30. So with the solar that we are able to put on the roof, and I do want to say that this is limited by just like the electrical capacity that's available in the building. So we had to size it to that, but it also fits pretty well with the roof area that we have to an extent. So in addition to, I think it was 39 tons of carbon dioxide reduction from just the efficiency measures, the solar would be an additional 38 reduction. So the production that we expect from the rooftop array on the municipal building would be about 13% of the existing electricity use, and then after the energy conservation measures are implemented, would be about 15% of the total energy. So not insignificant, but also working within the technical limitations that we have just from the size of the service that we have. That being said, I do want to point out that there was an additional electrical service brought in for the new electrical vehicle chargers, which I don't have the numbers on here. We weren't directly involved with, but that is, additional, not only additional electrical load, but additional savings. So we're expecting to see about like 110 kilowatts of solar on the roof. And again, size to, what we're able to work with the electrical capacity.
I have 3
Yeah.
questions. So to go back, what's the lifespan of the equipment, not the solar panels, but the equipment that's being added to the roof? And the roof itself?
Sure. Typical equipment that's on a roof lasts 15 to 20 years. The equipment that you have on the roof now is 15 to 20 years old, and so it's all at its end of life. So we expect to get a solid 20 years out of them if we can. The equipment that's within the building, the water source heat pumps that are already here, you should get a similar 20, maybe even more out of that. You may have to start replacing some parts. We found that a lot of the heat pumps in this building are also approaching their end of life, and so we're in the process of replacing heat pumps as well as these larger projects. And every unit that gets replaced is going to be replaced with something that's more efficient, just because modern equipment has gotten more efficient, and we expect to get another 20 years out of whatever you replace. Boilers, maybe 30 years. Cooling towers, maybe 30 years. But your typical rooftop unit, 15 to 20.
Aren't there solar panels going on the side as well, side of the building?
Not on like the side.
Yeah.
I didn't
So the plan that we have in place is all rooftop, and it's all solar photovoltaic. So they won't directly generate hot water, but they will tie in directly to the heat pumps that are consuming electricity. I'm not aware of solar panels on this along the sides. A lot of this analysis comes down to the angle of the panel and how much exposure it's going to get, how fully exposed it's going to be to the sun year round. Generally, vertically placed panels are going to really diminish the amount of energy that they generate. It may not even be worth it to do it. So I don't know if that was something that came up in discussion or not. That's new to me, but I know they did it at the football stadium. I think that was mostly for decoration. I'm not aware of it on this building.
And when you talk about the capacity, will that generate, the solar panels generate excess capacity that could then be used for the charging stations for the electric vehicles?
So if there is a time that these panels produce more than is consumed in the building, which at like this 13 to 15% is unlikely, it would be able to feed those other other consumption. However, good point though, because we will talk about the public works facility, which will overproduce and be able to virtual net meter to this building and help offset some additional consumption. Yeah, I don't really remember what all my slides were. So I just wanted to put this up here. This is basically from our facility analysis report. I just wanted to pull out the other things that can still be done. There are still some LED lighting upgrades, some automatic lighting controls. There had been some automatic lighting controls in this building in the past, but they weren't implemented very well and have been kind of de-implemented since. So I think there are some upgrades that we can do there. Some tweaks to the HVAC controls, which will be part and parcel to some of the equipment upgrades that it makes sense to make those upgrades before we make controls upgrades. But just kind of tweaking set points, some low or no cost things, including adding demand controlled ventilation. That's just adding some sensors and some control programming. Variable frequency drives to the cooling tower, heat pump domestic hot water heaters, and just standard plug load management like unplugging computers. So there's still more to be done, but we're getting the heavy hitters done. And also the necessary things like the roof replacement.
The VFDS to CT fan and pump.
Yeah.
That, as I understand it, when my heat pump at my house, when it turns on, it goes boom, turns on immediately. I hear it outside the compressor. Whereas I understand a variable speed drive would slowly ramp up and meet the demand wherever that demand for heat or cooling is.
Yep.
Instead of going full bore.
Exactly.
Suddenly it'll deliver, and that's a high efficiency, what eventually is the cold climate air source heat pump that I wish I had.
Definitely.
But I guess that's what you're talking here.
Exactly. So
And-
that's basically modulating the pump to meet the demand. It's
Yeah.
not just 100% or 50% or, wherever it's programmed to be.
and
And
the-
that is a significant source of energy savings.
Are you able to use in moderate cold temperatures, 50s, maybe upper 40s, the heat pump to warm the building, but not the hot water? Or are you committed to using hot water heat as well from the boiler, regardless of the cold temperature?
Sure. Yes, we can use the heat pumps to heat the building year-round. And it's because we have that boiler to provide, again, almost room temperature water to the heat pumps year-round. They always have a source of heat to draw from. We can run the boiler at very low loads,
Okay.
provide 70-degree water to the heat pumps. They can turn that into 100-degree air and run year-round without ever having to run the boiler up very high. You may have some perimeter baseboards around the windows or some areas that are designed to have higher temperature water to them, but they're really just supplemental to what your heat pumps are already doing. And because you have that boiler that's going to maintain a constant loop temperature, your heat pumps will be able to heat all year round, no matter how cold it gets. Yeah.
Yeah. Okay.
And that's the difference from water source heat pumps to air source heat pumps. Air source heat pumps used to be 40 degrees was the cutoff, and after that they needed either electric resistance or hot water backup. Air source heat pumps are getting much better. There are a lot of ones available that can go down to 13 or 0 or even negative temperatures. That's really not an issue with the system in your building because you have that boiler providing a neutral temperature all the time to those heat
Okay,
pumps.
so they're always working together.
They're always
to
working
heat the
together.
building.
True.
Yeah.
Yep.
Okay.
So with the public works facility, I'm noticing the time. So at least the public works facility is a lot more straightforward. We're mostly focusing on the roof replacement and the solar at this point. As you can tell from this bottom picture, probably there are significant issues with just like the roof structure and it's a drain pipe coming down, and it's real rusty, and that's because it's leaking. So for the public works facility, that is kind of the main approach there, and it still has. Not only is it going to improve the longevity of the structure itself and the comfort of those who work there, but it also is going to provide a significant amount of savings just by replacing the roof and increasing the insulation, bringing it up to code, is 8% of the entire site's energy, which is not insignificant just for a roof replacement that needs to be done anyway. So I just want to point that out. We are going to be removing some of the skylights from what is called the north shed. They're one of the main causes of the leaks that are happening, just the penetrations due to them. And the cost benefit of removing them and increasing some of the lighting is well worth the effort, not only for the longevity of the structure, but we can have a more contiguous roof for putting solar on. So we're doing the same stuff as far as black to white, but we can put a lot more solar on the roof. And so this figures here, we would be producing 200% of what the facility is using, just the public works facility. So that remainder, that 128,000 kWh, will be virtually net metered to probably the municipal building. It can be virtually net metered to any other Radnor-owned site within 2 miles of the public works facility, but this is definitely the largest consumer. And so that's an additional 15% of this building's energy use, and that's after completely satisfying the public works consumption. So take that off the top, the other then that can satisfy another 15% of this building's use. So I think we were about 15% before, so that's 30%. That's, yeah, it's awesome. And just using an asset that is there, and it's got a big roof. It's yeah, I'm really excited about that.
Yeah, that's great.
There are, again, I wanted to highlight again additional opportunities there for LEDs, thermostats, some additional heat pump replacements. Those are a little bit more, a little bit smaller beans compared to here, but not insignificant to look forward to. And I think the last point here I wanted to touch on is this is, especially for the roof replacements, so the bottom two chunks of that stack are the roof replacements, which definitely they needed to happen, whether or not they increase the energy efficiency. So that's over $2 million, and that's before we've actually gotten bids back. So that could change. It could increase, it could decrease, but that rough estimate. So if you look at the couple other stacks above that, the solar on both of the buildings is kind of pennies compared to the roof replacement. And then the heat pumps and rooftop units and boiler, is minuscule compared to that. However, the township has been gung-ho about pursuing any opportunity available to get funding. I think most significantly, the local share account grant of $500,000. That's the main part of that green donut there. And this is just for the most recent. I had alluded to some additional funds that were received for the EV charging. I think that was another 400 grand. That isn't even accounted for here because that isn't in the stack. There was some additional funding for from the Pennsylvania DEP MORE grant, which was technically for $50,000, but that's being applied to a loan interest rate buy down. So really, it's going to be more effectual than just the $50,000. I just didn't know the best way to quantify that in like a kind of grant type of way, but there are also going to be a lot of PICO incentives, not only from the equipment, but also for the solar. And there is, for now, the opportunity to take about 30% of the solar cost with the investment tax credit. Direct pay until anything changes with that. So there's a lot of effort and a lot of capital being put forth to improve these facilities and to improve like the comfort of these facilities, whether or not it improves energy efficiency, which is obviously a plus and part of calculus, but especially with the roof replacements, it was necessary. And there are just some benefits on top of it. So I don't want to take up too much more time, but I definitely wanted to highlight the things that were happening with Radnor, but also wanted to highlight a couple of other things that other municipalities are doing in a variety of different ways. So Ben, you've been more involved with most of these, but like especially for Springfield Township, we did some energy benchmarking for them, but a lot of our focus has been in basically that like low and no cost building automation system tweaks. I don't know if
Sure. Yeah, I can speak to it a bit. This was an effort really focused on their existing systems and their existing controls. And we did a similar analysis for this building. Some of those numbers that were on the screen earlier for things like building automation system upgrades, thermostat settings, that was really the focus on this project. They have a very different type of system in both buildings, whereas we have water source heat pumps here where every heat pump has its own thermostat. In these buildings, they had large air handlers with what we call variable air volume or VAV boxes. So you're sending a lot of air down a branch of duct, a large trunk of duct that's splitting off to individual zones that each have one of these damper controlled VAV boxes. So simply by looking through the trends of their BAS system, you also have a BAS system here that's pretty full functioning. You can see over time how systems are performing. We were able to see things like the boxes just aren't closing down enough. Even when there's no load in the space, they're stuck at 50%. Well, let's turn them down to 15%. And we immediately see a huge drop in fan power, a huge drop in cooling energy, and most importantly in the summer, VAV systems tend to need the boiler to keep running to reheat air that's been cooled too far. Because if the box can only close to 50%, but there's no need for cooling in the space, I'm still cooling the space even though nobody needs that cooling, which means then the heat comes on to reheat it back up and maintain temperature. So simply by reducing that minimum set point on those VAVs, we were able to decrease their energy usage by about 20%. Do you have a question? All right. We found the same thing across most of their buildings. We saw it in the library, we saw it in the administration building, the police department. They just actually asked us to come back and do another round of this to see if there's more that can be done. And we're finding, again, every time we look through the system, we find more things. So it's folks tend to think that when they get the digital control system in place, that it's a set it and forget it type of thing. It's going to run itself. It's going to always be efficient. But it really does require maintenance and monitoring and someone who cares and is thinking about the energy usage to really be continuously looking at how can we do better and what's maybe not going right, whether it's sensor errors or control sequences that can be improved. That's really fun for us, is to be able to look through these systems and pick out those things and see immediate savings without really any capital outlay.
Yeah, I really want to highlight there that these were like automation tweaks. Like there was maybe a couple $1,000s worth of our time and maybe a couple $1,000s worth of a controls contractor time. And they're seeing between the two, $16,000 a year in energy savings just by tweaking set points. And I think that's really cool.
Right. And really, it's set points that are not going to impact the comfort in the space. It's set points that are really going to take effect when no one is in the space or when there's no call for heating or cooling. We're never trying to make spaces less comfortable. We're really trying to make things more efficient when the heating and cooling is not needed, which is where things like variable frequency drives come into play. A lot of the energy stuff that we do has to do with letting everything slow down and you know, when it's not required. We have another one.
Yeah, I know we're about at 8 now, but so this one gets a little bit heady. I mostly just dropped in some eye charts here, but as another example of just like things that municipalities can do. This one's a little intense, but we were working with Upper Dublin Township. They got hit with one of those tornadoes a few years ago and lost their municipal building and I think their library as well. In any event, they had to completely rebuild their like municipal and police complex. So we helped them look at what options they had for energy efficiency. They have Ready for 100 goals and really understood that any new building is innately going to set them back on any renewable energy and zero emissions goals. New consumption has to be renewable in order for them to make strides towards those goals. So this was not entirely us. This was us working with their architect and their engineer. But I think this pretty much summarizes what we all came to. I think, Ben, you were more involved with this than I was. But they ended up going with the geothermal system, partially because of the federal investment tax credit, made it cost parity to a otherwise similar heat pump system, a ground source heat pump system with the 30% ITC, despite the additional capital cost for the drilling of the wells, made it the most cost-effective option. They not only went with the geothermal, but also as much on-site solar as was available. So they really dove into their commitments, and I have a lot of respect for them for that. This is a lot here. We don't have to dive into all of it, but it kind of summarizes the different conventional technologies. So we've got a ground source. So the GSHP is essentially a geothermal system. So whether or not that's with a dedicated outside air system, which is the DOAS, or a variable air volume, which is what Ben had been talking about just a couple of minutes ago, versus a conventional rooftop unit, third column, or a variable refrigerant flow, which is kind of a more efficient, souped up version. So all of that to be said, they went with the geothermal system, essentially the lowest cost system, thanks to the investment tax credit, and the lowest 20-year cost, like life cycle cost. So a little bit of an eye chart there, and I think I have a little bit more information there about pros and cons. And feel free to ask any questions. I don't know if we have the time or ability to go into the details, but happy to answer any questions. But that was another good example of, I think, the juxtaposition of Springfield that had existing systems that we made some tweaks versus a fully new system that we were able to make some impactful design decisions for.
This is indicative of the type of analysis we do for most clients. We did this similar sort of analysis for this building.
Is your contract with us going to have you, after hopefully all these upgrades are put in, to then look at the energy use and cost of the building and be able to compare that to the baseline pre-construction numbers?
I hope so.
So not as it stands, but we helped set up some of the kind of baseline information so that will be, whether it's us or others, it will be easy to make those.
I mean, is it something the township could just compare? I mean, I'm sure the costs, certainly they can do that for
Yeah, for sure.
electricity and gas and
Yeah,
volume
and
of
we've done
gas and-
like preliminary as far as like our projections for what has been proposed or contracted to be installed. Like the actual post implementation calculations are, I think, absolutely necessary, and I would love to do them.
Yeah, yeah.
But it's further down the road.
Okay.
Yeah,
Any other questions?
All right, thank you so much for
course.
coming.
Thank you.
yeah. I hope we didn't
Very
totally
helpful.
overwhelm with too much of technical information, but
Well, we do have a YouTube recording of this, so
wonderful.
we can all sit down with the YouTube
Perfect.
and
Yeah, no, and
with a
like,
dictionary and yeah.
if there are any follow-up questions, definitely pass them our way,
Okay.
and yeah, we'll answer.
Thank you.
Yeah, yeah.
Yeah. Okay.
So